Hello, welcome to this presentation. In this presentation, we are going to present the command design pattern. The goals for these presentations starts with a little example for having a motivation for this pattern. Then we are going to see which is the power of reification of actions. And finally, we are going to enter in the command design pattern. Let's start with an example. Imagine that we have a robot that we can script. With a string that has this shape, where we have the action to do and the parameter to the action. In this case, for example, take the direction to the east or move 2 units, or take the direction to the north and move 3 units. Let's see how we can implement this. Well, first, what we can do is take our string and splitting it on the new line character, so we have a collection of orders. For each order, we are going to have one string that we are going to again split, in this case, by the space character. Like that, we are going to have for each order a pair that is the operation and the parameter for this operation. So later, we can take our collection of orders, then in this case the variable orders will contain an array where we will have a pair with the first element will be the order and then the parameter of it. Then, for example, we can have one dir north and so on. This is the structure that we have in our collections of orders. So we are going to take each of them and we are going to see if the operation is move, we are going to tell the robot to do this operation, parsing the second argument. The same, if this is not move, we are going to check if it's a dir operation and we are going to execute that. As we see, we have conditional code that will test each of the actions that we are doing. Now let's see what happens when we try to add more operations to our robot. Imagine that we want to add a pick operation or a drop operation or a return operation that takes back the robot to the base. In this case, what we are going to do is adding more and more conditional code on it. As we had before, just asking for move and dir, now we are going to ask for if it's a drop, pick, or first. Seeing that adding here more and more operations, what does it does is that we have more conditional code, increasing the amount of complexity of this method. Each time we add a new operation, we are going to have a longer method that has more and more complex conditional code. So let's analyze up to here the example that we have. In this example, when we add a new order, we have to modify exactly the same method all the time. Adding them is highly expensive because we have to improve the complexity of this method. Adding more and more orders, finish with a really big execute method. Also, imagine if we want to have orders that are more complex. In this scenario, we can have an order that allows us to execute many moves at the same time. Let's see, for example, if moving once, executing move 10, and move 10 is more expensive, we can unify them in a single move 30. Doing the 3, instead of doing 3 moves, doing only 1. In this case, well, we will have our text that represents the action, the string, they are just strings, and manipulating strings to compact them in something that is move 30 is complex. We want to have objects to manipulate them because they are easy to modify. Also, let's see another example where our solution is really short, is that what happens if we want to replay this action that we have done, but in the inverse order to make it come back to the home base, for example. Well, you can tell me, okay, we are going to iterate now the string in backwards, but that again is complex. We want to have a better solution. So in this example, let's introduce the idea of the common design pattern. This is the intention that we have taken from the design pattern book from the Gano 4, but it says exactly what we want. We want to encapsulate, in this case, the operations as objects. Request or operations as an object. Then letting like this, as we have objects, we can start parameterizing them by the client, modifying them, for example, for each of the operations, saying the parameters to use or the order to execute it. And then as we have objects, we can do operations on them. We can queue them, we can log them, we can undo them, or we can, for example, compact many of them in a single operation or do whatever operation we want, because now we have objects and they are more powerful than having just a text representation. Basically, a command is just a reification of an order or an action. Is something that we want to create as an object that in case will represent an order or an action on a more complex object. Usually in a command, we are going to encapsulate more than just the action that we are executing. We are going to encapsulate all the context, all the elements that it needs to execute. For example, we can encapsulate all the parameters. We can encapsulate how this is log, or, for example, information to create a menu or how to display this action. And commands are really useful when we want to have undo operations, because as we are going to create a list of objects with each of our actions, we can keep this list and basically reverse the order and execute. Instead of executing in the first order, we can execute it in them back in an undo fashion. And as each action, as each command knows what are the arguments and what is doing, is easy to implement a reverse operation. In the case of the robot, if it has turned it to the east, we can make it turn it in the west direction. Which is basically the structure of a command? Well, we have two roles clearly defined. In one side, we have the client of our command pattern, and then we will have the object that we are modifying with these actions. Then we are going to have concrete objects representing each of the operations that we want. In this case, it's common that we have a common abstract superclass between the concrete commands, but this is not required. Usually is decided because we are going to put all the common behavior in the superclass. But that is just a decision. We can have a command design pattern just using a polymorphic message. That is the most important thing, because who will create the action, will create the command, will configure it, and eventually somebody will send the message execute to execute it in a polymorphic way. It's the same if it executes the concrete action 1 or the concrete command 2. Let's see our example in action. Let's put the design pattern in our example. In this case, we are going to create a superclass in common, a common abstract superclass, but the important thing is that we are going to create an object for each of the operations that we have. In this case, we are going to create one for the direction command, and we are going to give in it the direction that we want to turn. In this case, in our solution, we are going to have two methods in our command. In one side, we are going to have a method to handle the arguments, to parse the arguments and store it in the correct values for the command, storing in the instance variable direction the value that has extracted. And then we will have an execute on that will do the action. Each of the operations, each of the commands will do is a specific action depending on what we are doing. For the move, we have exactly the same. For the move, in this case, we are going to get the argument direction from the arguments and we are going to extract it. In this case, the commands are simple and just has one argument, but this same architecture, this same solution, can be used to extract more complex arguments from the collection of orders. And then exactly the same, when we are executing the action on the robot, we are going to delegate the correct action into the robot. As we see now, the execute command will be much simpler. We are going to have exactly the same code to parse the strings, but later, when we are executing each of the orders, we are going to delegate to the command to execute. We are going to decide which is the command to execute, just create a new instance, pass it the arguments, and execute it. So in this case, we are going to create this command for class. We'll delegate in each of the commands and ask if the given string that represents the command applies for each of them. As we see in this example, we have reduced all the conditional code, all the boilerplate code that we had before that was not adding, it was just adding complexity to our solution. In this case, the solution is much easier because we are just delegating into the correct class. In our scenario, if we want just to add new commands to our robot, we just add new classes extending by command. And each command is now responsible for handling the arguments and the information needed to perform the action. It also encapsulates the applicability and what to do in this action. This is important because now we have an object that we can use to ask and demand information. And now we have a collection of objects that we can do many things. For example, we can log them, we can sort them in the correct order, we can undo it, we can merge them if they are needed, because we have objects and we now have a better representation for our actions. But there are always consequences of using a design pattern, and in this case it's not different. Well, not all operations that we have in our solution should be turned into command objects. Because basically when we start adding more and more commands, we are going to have a large hierarchy of simple classes that will grow and grow. So we need to select which are the operations that we want to represent as commands. Also, it's important that we keep the behavior of the object that is exposing the actions inside the object, because if not, we can tend to break the encapsulation and break the nature of the object. If the robot just do nothing now, we are going to have a problem. It's not a nice solution. As a conclusion, you have to think the main idea in the design pattern is that we are going to take actions and we are going to take orders and operations and we are going to reify them as objects. We are going to create first-class citizens for these operations, and so like that we can use it as any other object in our system. This solution is great when we have to do operations like undoing the operations that we have executed. We have a list of operations and then we want to reverse them in order and undo them. When we want to replay the same, when we want to optimize before executing, or when we are delaying the execution between the creation of the objects and this real execution.